All right, here's a continuation of graphing radical functions. We've already talked about the transformations. So here's just a review of where the a, h, and k are important for us. Again, we do not have to worry about the horizontal stretches and compressions. So you can cross that off. Example 1, use the description to write the square root function g of x. The parent function is f of x equals the square root of x. So what we're going to do is we're going to reflect it across the x-axis. So when we reflect it across the x-axis, we're going to have a negative in front of the square root. It's going to be compressed vertically by a factor of 1/5, so that's a multiplier, so that happens in front of the function. And then it's going to be translated down 5, so it's going to happen outside the function, that's our k, so minus 5. Second example, we're going to reflect across the x-axis again, so a negative. We're going to have a vertical stretch by 4, so multiply by 4. Square root of x. We're going to move to the right 3, so that happens inside the radical. Think opposite, so right 3, so we're going to go minus 3. And then up 1, that happens outside the function, so plus 1. Okay, we're going to go ahead and graph this function, so we're going to evaluate the function. So I'm just going to choose numbers like 0, 1, 4, and 9. The reason why I'm choosing those numbers is they are all perfect squares, because the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. All right, so let's go ahead and substitute those in. So 2 square root of 0 minus 3. So the square root of 0 is 0. 2 times 0 is 0. 0 minus 3 is negative 3. 2 square root of 1 minus 3. The square root of 1 is 1. 2 times 1 is 2. 2 minus 3 is negative 1. 2 square roots of 4 minus 3. The square root of 4 is 2. 2 times 2 is 4. Minus 3 is 1. 2 square roots of 9 minus 3. The square root of 9 is 3. 2 times 3 is 6. Minus 3 is 3. So let's go ahead and graph it. So the first ordered pair is 0, negative 3. So over 0, down 3. Then 1, negative 1. So over 1, down 1. 4, 1. So right 4, up 1. And then 9, 3. So right 9, up 3. So here is our new function. Our domain is x greater than or equal to 0. And our range, notice our range, our lowest y number is negative 3. So y greater than or equal to negative 3. All right, here's another one. We're going to go ahead and evaluate the function this time. I'm going to choose, this is telling me, highlight this, this is telling me it's going to go to the left 2. So when I choose my first x value, I'm going to go left 2 and evaluate it. So our first transformation is left 2 and then up 3. So in our original parent, we would be at 0, 0. Now we're going to be moving left 2 and up 3. So our first point is going to be right there. So let's go ahead and evaluate the function. So we're going to substitute negative 2 in for x. Now we're going to simplify it. Negative 2 plus 2 is 0. The square root of 0 is 0. And we get 3. So we're left 2, up 3. Now I'm going to choose -1. So -1 plus 2, and then plus 3. The square root of 1 plus 3. The square root of 1 is 1. 1 plus 3 is 4. And then 0. 0 plus 2 plus 3. We get the square root of 2 plus 3. The square root of 2 is approximately 1.4. So we get 4.4. So over 0, up 4.4. The domain is x greater than or equal to -2, and the range is y greater than or equal to 3.